We are living through a noisy revolution. From crickets to construction, frogs to freight trains, all sorts of sounds fill our ears every day. And those sounds don't just affect us humans, they can impact animals all around us too. Take, for example, this ornate tree frog. It needs to stay silent to avoid predators during the day, but it needs to make a lot of noise at night to attract a mate. But if it's calling in a noisy area, it could end up attracting the wrong kind of listener. And no, I don't mean like some supervillain who wants to capture the frog and harness its power for evil. I mean a predator looking for a tasty snack. In an increasingly loud world, the frog and many other species have to change their behaviors to survive, which is what makes understanding sensory ecology so important. Animals rely on senses like hearing, sight, and smell to get through the day, from finding food to avoiding predators to attracting mates. Sensory ecology is the study of how animals sense their surroundings, how they process that sensory information, and how they use it to behave. So today, we're going to explore how animals use acoustic, chemical, and visual signals to navigate changing environments, such as coral reefs, deserts, or forests with increasing human noise or light. And we'll learn how sensory ecology can help us reduce sensory traps, such as bird collisions or pollution. One thing scientists look at is how animals sense the world around them. Some animals, like dogs, have acute hearing, enabling them to pick up sounds beyond the range of human hearing. Some birds can hear sounds as high as 13,000 hertz, whereas the highest most humans can hear is around 20,000 hertz. Sounds enter a dog's ear and vibrate the eardrum, which sends signals along the auditory nerve to the brain. Meanwhile, vibrations travel through the fluid-filled inner ear and stimulate hair cells, which convert the mechanical energy of sound waves into electrical signals that the brain can understand. Dogs have more hair cells and a different arrangement of bones in their middle ear than humans, which allows them to hear lower frequency sounds better. These lower frequencies can travel through solid objects and even penetrate closed doors, which is why a dog might hear you before you're visible. While humans can detect higher frequencies, which may be better for hearing speech, dogs can pick up lower frequencies that indicate something like an approaching car engine. Being able to hear these lower frequencies may help them detect approaching cars and safely navigate busy streets. But when there's a lot of noise in the air, it can make it harder for animals to hear sounds that are important to their survival. For example, noisy machinery used in mining operations has been shown to drown out the calls of endangered golden-bellied tree frogs, making it harder for them to find mates. Noise pollution can also mask the warning calls of other animals like birds. When white-throated sparrows were tested in a noisy environment, they were less likely to respond to the alarm calls of northern mockingbirds than in a quiet environment. That means that if you're out in a noisy environment like a city, you might not hear a warning call from a bird and then get startled by a swooping hawk. But the good news is that by understanding how animal hearing works, we can create quieter technologies and equipment that have less impact on wildlife. Aside from hearing, animals use other senses to navigate their surroundings. Consider the tiny coral reef fish called a damselfish. They live in a three-dimensional world full of objects like rocks, algae, and coral. So to see clearly, they need to control how light enters their eyes. Damselfish have special muscles that change the shape of their pupil to let in the right amount of light. In bright conditions, their pupils become vertical slits to reduce how much light gets in. But in dimmer conditions, their pupils become circular to let in as much light as possible. The damselfish's eyes are also on the top of their head, so they can see above them while hiding behind coral. This is an adaptation that helps them keep an eye out for predators while staying camouflaged. So as long as they don't run off into the blue, they should be safe from predators. Animals use smells to gather information too. Male plainfin midshipman fish release a pheromone that attracts females ready to mate. The female plainfin midshipman fish have special receptors in their noses that allow them to detect these pheromones. Using their noses, they can also detect danger. If the fish smells a predator nearby, it can turn tail and flee. And although our sense of smell isn't nearly as good as that of a dog or a fish, we can still use smells to figure things out. Just think about how you can tell when something is burning by smelling smoke, even if you can't see the fire yet. Smells like that are known as alarm cues, and they can help protect us from harm. So far, we've talked about how animals sense their environment, but sensory ecology is also about how animals process sensory information and how they use it to behave. For example, male orb-weaving spiders produce silk pads to help catch and hold on to their prey. But these silk pads can also pick up vibrations made by hungry birds searching for a snack. The spiders can use these vibrations to figure out if the bird is interested in eating them or their web. If the spider senses an approaching bird, it will release its web, saving itself a nasty fate. And black-crowned night herons use visual landmarks to help them find their way back to their nest. These birds prefer to build their nests near water, but away from predators. They use visual cues like the position of the sun or moon to orient themselves, enabling them to navigate to their nest at night. That way, they don't waste time and energy flying around randomly looking for it. In addition to helping animals understand their surroundings, sensory ecology plays a crucial role in informing conservation strategies. One strategy is reducing sensory traps, which are situations where animals experience negative consequences because of a sensory cue. For instance, as more glass skyscrapers and office buildings are constructed, birds can collide with them. Birds often see the reflection of the sky or clouds in glass windows and fly right into them. Between 2009 and 2014, an estimated 500 million to 1 billion birds died each year in the US from window collisions. To reduce these collisions, one approach is to install decals or screens on windows to break up the reflection and make it more obvious that there is a barrier there. And since most birds that collide with buildings are only doing so because they trying to get somewhere else, installing decals that point in the direction the bird is traveling can help guide them away from the building. Another type of sensory trap is light pollution. Artificial lights at night can interfere with the navigation of nocturnal animals. For example, turtles that hatch on brightly lit beaches are more likely to crawl toward the lights than toward the ocean. And sea turtles aren't the only ones. Hatchling loggerhead turtles crawl toward the brightest light source, often ending up on roads instead of in the sea. On their journey to the sea, they can face many dangers, including cars, predators, and people. To prevent this, some coastal towns have installed special turtle-friendly lighting that minimizes the amount of light that reaches the ground, helping baby turtles find their way to the sea more easily. Sensory ecology also helps us reduce auditory traps. Many animals are affected by noise pollution, whether it's the noise of traffic, construction, or industrial activity. These noises can make it hard for animals to communicate, find food, or avoid predators. For example, increased noise levels have been linked to declines in the populations of several amphibian species. Loud noises can also hurt our ears. Prolonged exposure to sounds over 80 decibels can damage our hearing. That's about the level of a busy street or a blender. And the louder the sound and the longer the exposure, the more likely hearing loss is to occur. The good news is that we can take steps to protect our hearing, such as wearing earplugs in noisy environments and taking breaks from earbuds and headphones. From frogs to turtles to us humans, animals all over the world rely on their senses to navigate their surroundings. Understanding how animals sense their environment and how their sensory systems work can help us reduce sensory traps and protect animals and ourselves from harm. So whether it's reducing light pollution, protecting habitats, or reducing noise pollution, by learning more about sensory ecology, we can help create a world that works for everyone. And we want to thank all of our supporters for helping us make this video. You've helped us bring important topics like sensory ecology to viewers all over the world. Supporters also get access to perks like submitting questions to our inbox, blooper reels, and more. To learn how you can support us, visit our support page.